Mike, you're going to talk to us now about some cool things like slicing and the old special circuits in a way. So why don't you take it away?
Thank you. I guess I'm a little taller than you. Okay. All right. Yeah, welcome to the session here. Appreciate you guys giving us this time. We're going to talk about a few topics here for this session. Some of them are going to be our next generation PON technologies that were also touched on in the previous session. We'll also talk about the use of end-to-end network slicing. So we'll talk about some of the differences in the network slicing technologies. And then the third topic I'm going to bring up is an OLT with a disaggregated BNG. And so these are going to be capable of enabling new revenue streams while reducing complexity, operational costs, and even capital costs. All right. So we see all of those three fundamental technology shifts being game changers. So next generation PON technology, think 50 gig and beyond, end-to-end network slicing. So think network slicing that's going to go through the core as well as PON slicing technology. And then also the combination then of an OLT and a BNG. So when we look at all of these game changers, we're going to see that by using these technologies, we'll be able to have more revenue streams and higher ARPU across this network infrastructure, capable of delivering perhaps new services across PON technology, business, mobile offload, mobile xHaul, and then overall transport services, maybe to consolidate access and aggregation layer technologies into one platform and then over one technology, PON. So we also think that we'll have the highest capacity using PON technology with the lowest cost per bit. And then we also think this is going to be the greenest solution. So there'll be higher capacity at lower space and power utilization. All right, so what are some of the drivers beyond 10 gig PON? So think XGS technology. So we broke them up into three categories: business services, so small, medium, large business that might want something over 8.5 gigabits or the capacity of XGS. And then we also looked at the use of some of the PON slicing technologies to carve out a portion of that capacity, perhaps in the 50 gig area, for groups of subscribers. Talked about this earlier. Maybe what we could look at is the consolidation of the access layer as well as the aggregation layer to one platform and one overall network technology. And then that using PON technology as an aggregation layer to connect and transport wireless services, mobile xHaul, front haul, mid haul, back haul, and then also Wi-Fi 7 access points that might be throughout the community, maybe at venue locations, etc. And then also just overall distributed access architectures. Some of those distributed access architectures could be in MDU locations that have different technologies, perhaps coaxial technologies, or even for the MSO community that might have nodes for their DOCSIS infrastructure that needs transport. And then also cabinet locations could be another use of 50 gig PON technology, for example, for the transport and aggregation of those distributed access architectures. And then finally, residential. So residential does continue to have higher billboard speeds. Those wars will likely continue for some time, and I'll have a slide that talks about that. And then also beyond just the top service tier, we can also look at customer traffic trends, and that though they have been declining, they're still growing. All right, so if we look at some of the services in three of those segments that I talked about, I just identified here about a dozen use cases or so. And then in those dozen use cases, I've named them and then applied what type of capacity would be needed per use case. When you look at the Wi-Fi access points and the aggregation services segment, I got this data from the IEEE in terms of how much maximum throughput could be expected over the life of Wi-Fi 7. Certainly, it might be less in some deployments, some different architectures, etc. 5G mid-haul and backhaul, I took this from the ORAN specification, working group 9. they gave guidance to the service providers about how much capacity they needed to have at small, medium, and large sites. And then, of course, I talked about residential service tier growth. And then all of this is showing that to consolidate all of these services and segments across one infrastructure, 50 gig could be that next generation PON that we leap to have this network consolidation. All right, I talked about residential services. This is Nielsen's Law. It's been around since 1983. It's been fairly accurate over the last 40 years. And what it says is that the maximum or highest service tier offered by a service provider for residential type applications grows at about a 50% compound annual growth rate. So beginning in 1984, we had about 300 bits per second would have been that maximum service tier. So as we looked over the last 40 years, it's been pretty accurate. However, the last few years, with technology enhancements, we've been able to increase or go beyond 50% compound annual growth rates. And I've identified them here. In 2022, depending on where you were, you could have seen a 5 or 8 gigabit service tier. And in 2024, you could have saw a 20 gigabit service tier. Nielsen's Law would have predicted a 3.3 gigabit service tier by 2024. So massively exceeding that 50% compound annual growth rate that Nielsen's Law has been fairly accurate at predicting since 1984. So where are we going? Well, we're going to make some predictions here, and we think that maybe in the 2035, 2036 timeframe, that we think Nielsen's Law will break. It's going to break for a couple of reasons. One is that the PON technology advancements aren't going to be able to keep up with that timeline. And since PON is likely the technology used in the residential space because it's cost effective, we see that that could be one of the pillars of why Nielsen's Law may break by 2035, 2036. Speeds are just not becoming noticeable. So as we get higher and higher, no one really knows how much capacity that they really have or are paying for. That they certainly couldn't tell likely the difference between some of these 1, 2, or 3 gigabit service tiers. From a speed test perspective, perhaps maybe that's the only one. And then the economics, okay? Next up, I'm gonna shift gears from service tier, what marketing essentially offers to subscribers and what a subscriber would pay for, to what the actual customers are using, traffic, okay? So if we look back all the way back to 2000, we had about 6 kilobits per sub, busy hour, busy day. So 6 kilobits per sub, busy hour, busy day in the year 2000. Fast forward all the way to 2022, 3,500. We went from 6 to 3,500 kilobits per sub, busy hour, busy day. Represents about a 33% compound annual growth rate. But the last 10 years, from 2012 to 2022, in this chart, 31%. And then the last 5, from 2017 to 2022, we had about a 26. So you can see that there is a decline. But if we forecast that out, perhaps using a 20% compound annual growth rate, in 2030 timeframe, we might have a 15 megabit busy hour, busy day projection. And by 2040, maybe 93 megabits per sub, busy hour, busy day. So when we look at the service tier growth, the network capacity that we've talked about in terms of the different PON technologies, and then also how many customers might be sharing an infrastructure and how much those customers might be using busy hour, busy day. What I have here is some projections to determine how long some of these technologies will last. What I've identified here is based on 32 subs or 64 subs, you might see an XGS having different periods where they might be exhausted in terms of the ability for them to pass a speed test based on how many subscribers they have and what's their top service tier offering, whether it be 8 or 5. If we look at 25 gigabit PON technology that was talked about as well, and a 20 gigabit service tier, which has been offered by a service provider, That might last perhaps until 2030 or 2034 based on some of these projections, okay? We look at 50 gig. 50 gig has much more capacity, obviously, and it can last longer, okay? And what I'm showing here is, 40 gigabits worth of capacity at 32 subs by 2038, and by 2040, 35 gigabits available. So now we're going to look at what are some of the technologies then that could enable these, okay? So we talked about 10 gig, and it has a capacity limit of 8.5 gigabits. 25 gigabits, though, has a capacity limit of about 21, and 50 gig has a capacity limit of about 42 gigabits usable. One of the interesting things about 50 gig PON technology is that it can support both 50 gig by 25 gig ONUs and 50 gig by 50 gig ONUs on the same fiber, same lambda, same port on your OLT, providing some economic flexibility. So many operators and system vendors are skipping the 25 gig step. It's just not enough capacity to last a long time based on service tier growth as well as traffic growth. That that growth between 10 gig and 25 gig just wasn't a lot. And if you look back over the last 30 years of PON technology, we've seen about a 4 times increase in capacity with each generation of PON technology that's been released. So one of the things I'll touch on here is wavelengths. There are wavelengths to support GPON and XGS today, as we know, and then we've identified a wavelength that can support 50 gig or 25 gig. And some of those XGS and GPON wavelengths can support either 50 or 25 if they're not in use. One of the things that we're suggesting to many of the service providers is that if you have GPON used and XGS, you have one wavelength left. Our recommendation then is to save that last wavelength for 50. And GPON could be one of the wavelengths that Frank talked about in the previous session that could be used for 100 gig or more of capacity. All right, I talked about this earlier. This is an illustration of the capabilities that 50 gig has. 50 gig has the capabilities of supporting 50 gig downstream, 25 gig upstream ONUs, and 50 gig by 50 gig ONUs on the same fiber, same wavelength, same OLT. Why is this important? Well, it's likely 50 gig by 25 gig ONUs are going to be much cheaper, much more cost effective to deploy than 50 by 50. So this offers operators economic flexibility. Network slicing. So this is an illustration of the network slicing technologies. So this is an end-to-end view. So if we look from right to left, essentially from the subscriber or the edge, and we look at the scope of the IEEE, it's going to be defining some Wi-Fi slicing technologies. If you look at 3GPP, we've heard about 5G slicing in the wireless industry. Those technologies need to be transported. I'm suggesting here that 50 gig PON technology could be that transport. We can use a supplement that was defined in the ITU, supplement 74, to implement PON slicing from the ONU and OLT. As we leave the PON layer and go across the core of the network, we can use IETF-defined network slicing technology called segment routing. So this is an end-to-end view to illustrate the use of various network slicing technologies for an end-to-end network architecture. What is PON slicing? PON slicing is taking a physical network architecture, a physical network port, and then logically partitioning it out. I'm going to show a couple of examples here. One is a way of grouping groups of customers into a particular slice of capacity and latency parameters, carving up that 50 gig network. This is an illustration then of a single ONU being carved up into multiple slices, okay? So the first illustration was per ONU, grouping customers based on a group of ONU assignments. Second is going to be based on a service type. OLT with disaggregated B and G. So if we look at the technologies being defined in the broadband forum for many years, they define a B and G. That B and G provide provided traffic management, essentially enforcement of the service tiers, upstream, downstream, rate limiting, counting, statistics, lawful intercept, among others. But they also defined standards to disaggregate the BNG, separating the management and control from the user plane or the service plane, essentially what customers actually use. And I'm highlighting those in blue as well as yellow. I'm going to highlight a few here. So the most important thing about what a BNG does is an area called traffic management. It ensures that the service tier that a service provider is selling to their customers and a systems and chip vendors are enabling through their technologies can be enforced. That traffic management will make sure that the upstream and downstream that the customer pays for is received, is guaranteed, or maximum burst rate. The costs for different types of traffic is enforced at the traffic management layer. So I've highlighted that here. Subscriber packet counting. Some of the operators want to keep track of how much traffic's being used per service type, per customer, etc. So this is the most important area. The other areas are lawful intercept, subscriber routing, local control plane functions, etc. I'm going to show you a couple of illustrations here about the evolution of the PON architecture. So many years ago, around, let's just say at the turn of the millennium here, 2004, let's just say, in that time frame, we've had some of the first PON deployments happen. And they essentially replicated the DSL architecture that started 30 years ago. They had a simple access layer network element that really didn't do any of this traffic management, and they steered all the traffic to a central location called the BNG. I'm highlighting that in the yellow box. That does the subscriber packet counting as well as that traffic management. And that's what PON adopted, essentially replicating the DSL architecture. So there's been a movement to try to virtualize some of our network functions, like, for example, the BNG. Virtualizing meaning run across an x86 server complex or infrastructure, because it's not just a server. It's the leaf spine switches and routers that need to steer that traffic through the servers in and out. And that's what the traffic flow looks like. Traffic goes in and out, hairpinning in and out, just for one major thing: traffic flow, traffic management, making sure that the bits paid for are enforced, okay? But there's another architecture. The other architecture is moving and combining the BNG traffic management functions with the OLT. And this architecture has been actually deployed for many years. In fact, combining the traffic enforcement and at the access layer was done over 25 years ago in the cable industry in a device called the CMTS. And then in 2010, when cable entered the PON space in a significant way, then the OLTs combined all of that too. And then Verizon did public announcements in 2018 combining OLTs with BNGs. And of course, the Broadband Forum started to define standards that could disaggregate management and control plane as well as the data plane. Where that data plane lived was up to the operator. They didn't care. These are the architectures that could be used. This architecture on the far right combines those functions with an OLT. So this is a key question we have to ask ourselves as an industry. Do we want, in the 50 gig era and 100 gig era, steering traffic in and out of an x86 ASIC for a virtual BNG architecture? Or do we want that traffic management function pushed all the way as close to the edge as possible for edge computing at line rate? So here's an illustration then. In the interest of time, I'm just going to just say that this is a part of a paper that was published last year at the SCTE. We'll have it on our website in the next 3 weeks. But this illustrates examples of network slicing end-to-end and an overall architecture that talks about what I've just covered in this presentation. With that, I thank you for your time.
Thank you, Mike. That was a great slice of a slicing. So.